Good day. My name is Brian Strickland, and this is my um, project presentation on network analysis of real-time chat applications using Node.js, Socket.io, and the Django channels. So first off, introduction. So there are various languages and frameworks that developers can use to build real-time chat applications on. Doesn't matter what language they use. Well, this research was to do a comparative analysis to see what impacts um, developing this type of application on the Django or Node.js would have on network traffic volume and traffic latency. This can be important because um, depending on the volume getting sent, um, where you have your application hosted, there could be a cost savings. Um, there's also a network bandwidth savings by putting less um, packets over the network as well as energy savings. So my explanation of an algorithm. Um, so the objective, I ran n simulations with n messages, and I compared the results of Node and the Django real-time chat applications. The metrics I used were the network volume and the network latency. Uh, the measurements for this was for the network volume. It was just a simple summation of all the bytes that got sent over, and the network latency was just an average of all the simulations that ran, the average it took for all the transmissions to complete. The test scenarios I used were an on-prem to on-prem connection, as well as an off-prem to on-prem connection. My data collection process. Um, so I collected data from both real-time chat applications, um, and I collected this data so that I could do network traffic volume and latency analysis. And to actually find that data, I used a program called Wireshark, which enabled me to capture the data being transmitted over my Ethernet card adapter. So my data collection process methodology, um, I developed very bare bones, simple real-time chat applications using both Python and JavaScript, and they ran using Node and Django. The Django channels was used for real-time chat communication for Python applications. Socket.io was used for the JavaScript application. Um, my internal network modifications have been made to actually enable other devices and outside devices to connect to these applications, various firewall settings, port configurations, etc. And to simulate the environment, I had an Ethernet, Wi-Fi, and cellular network that was used. So with my test for network volume, I just did simple 5 messages I sent to each one. I didn't just use Wireshark to see the data load getting sent there. There's no need to send thousands of messages. For the network latency, I ran 2 simulations. One was a manual of 100 messages getting sent. It was semi-manual, semi-automated. And then I ran a automated simulation that would send 2,500 messages over the network. To find this data, um, I use filters in Wireshark. Um, the main ones that I was really using was just the TPC port to just isolate the data traffic for each of those applications. But I did do an experiment with to see how many, what was the network volume to establish and terminate connections as well. So for that, I was using the SYN ACK and SYN flags to identify those packets. My evaluation of my environment. So The Node and Django applications were were built on top of Windows Linux WSL environment. I did this just because that's where I have all my development set up. In hindsight, I would have tried to make a more isolated environment, um, but I just didn't do that approach for this project. The network consisted with Wi-Fi, Ethernet, and cellular networks. The Wireshark was then used to collect the packets, and when this packet data was filtered, it was exported to Excel and to Jupyter for additional analysis. I had planned on doing analysis with a cloud environment as well. I went so far as to where I had two Azure App Services stood up in Azure. Code changes were automatically being deployed. You could visit the websites, but when I went to go do the network analysis, I realized that I can't. Azure App Services is a PaaS offering, which is a platform as a service. That basically means there is no infrastructure behind it. So I couldn't put something like Wireshark in the middle of the sniff the traffic. I could have went the route of creating a virtual environment within Azure with virtual machines, but that would have just simulated what I was doing on-prem. So no cloud tests were done. The evaluation of my data volume was the Django had an impressive reduction in the amount of data being sent. With these visualizations here, these are just the tests where I was sending a full message 5 times to both applications, both on-prem and off-prem. And as you can see here, Node is actually sending quite a bit more data for each of these protocols. In terms of the amount of data required to establish the connection as well as terminate it, you can see the Django outperformed. Node really suffered when it came to the off-prem to on-prem connections. Then I noticed looking while I was doing this experiment, every 25 seconds or so, there's a ping pong getting sent to keep the WebSocket alive. This could be an area improvement because even if data is getting transmitted, the ping pong still happen. So that was interesting to see. I isolated where that's happening in Socket.io. I didn't see it in the channels, but I was able to verify that there is a process that is going. So you could, if you wanted to, you could make your own version of Socket.io and just remove that ping pong to make an improvement. But that was out of scope for this research. For the message latency, Node surprisingly outperformed the Django on this. Even though it's sending more bytes, it seemed to be faster. The first simulations I ran were just, I had a button I would click that would automatically send 100 messages. And I was thinking, well, maybe it's just because this is semi-manual. Let me do a larger load. So what I did then was I developed a way to automatically send 2,500 messages. It basically ran that same simulation, but automated it 25 times. And even then, Node still, not by much, but Node still had a lower latency than the Django. My thoughts there are that the Django is doing some kind of algorithm in the background to lower the bytes. So even though it's sending less data volume, it's suffering with the latency. So discussion and conclusion, the Django is 78% more efficient at handling data than Node. Node is 26% more efficient in terms of the latency. And with less data going over the wire, this could be potential cost benefits. Not much, but depending on what your hosting environment is and how much data you're actually getting sent. There may be a reason to choose the Django. So now I will finish up and conclude with a demo. So what I'm using here is I will be using my Ubuntu virtual machine. The reason for this is I want to do an outside connection from my IP address. Otherwise, we're not going to see the packets come over the wire because it'll all just be in the internal network. So before I can get that to run, we're going to have to actually start the services. So I'm just here. I built a little script here to automatically start these environments, so the proxy networks, etc. So we'll just run this. You can see here, it's starting up the node just started, and then the the Django app just started here. So you can see a connection was actually just made. So let's go back. If we go reload this, it should load now. Demos. There we go. It loaded. So let's see. So what I'm going to do here is I'm going to run a simulation of 11 times 100. So 1100 messages are going to get sent. So what we will do is we will filter the traffic for 8,000. Go ahead and start listening. Nothing's coming yet, but there's probably a keep alive. So I ended up having to stop the video and restart it because for whatever reason the Ubuntu server is not working. So what I'm going to do to show the test and capture it is I've got an iPad and it's connected to the external, to the IP address of my home network via cellular network. So what we'll do here is I'll go ahead and share Wireshark's traffic. We'll go ahead and stop it and restart. So what I'm going to do here is run a simulation as before. It's in 1100. And as I hit this button now, you should start seeing the network come. Here you go. You're seeing the traffic. And so what I was doing was I was finding, I exported all this data. You can see here the chat messages getting sent. Message run 8, message 48. So there's a run 1 through 11, all the way to message 1 through 100. All that data was taken from here and exported to Excel to do that analysis. But that is my demo. Looking forward to class on Tuesday. Thank you.